I knew you'd be back. I knew you'd be back. You can't stay away. I've just got that type of magnetism, I guess. All right, we are going to continue the 2017 Calculus AB exam. We are on the free response questions, FRQ, free response questions, and we are doing question number 2. And for all of you guys that are starting to sweat bullets, don't worry, we get to use our graphing calculator because it is required for these questions. Thank goodness. Let's start. Number 2. My, that's a fancy graph. During the time interval where t is greater than or equal to 0 and less than or equal to 4.5 hours, water flows into tank A at a rate of AT. So let me first establish this. Here's the rate of A. It's this equation. And that's this graph right here. All right? Liters per hour. During the same time interval, water flows into tank B at a rate of BT. Okay? We don't have an equation, but we have a graph. All right? Both tanks are empty at time 0. That's pretty important. The graphs of AT and BT are shown in the figure above, and they intersect where t equals k and also where t equals 2.416. Now, I think I might have said this before. We get a lot of information up front, and we might not need to use it all for the first part, for A or for B. But at some point, we might have to use some of it for a further question, B, C, D, whatever. A says how much water will be in the tank A at time 4.5. So I really don't need this graph at all for that, okay? Now, if you watch free response question 1, I did a quick review here as far as the connection between position or quantity, I guess you can call this as well. Then there's rate, which is it all moves down. Okay, there's position, velocity, and acceleration, right? Then there's quantity, the rate at that quantity, and the acceleration, or the change of the rate. Okay, these are all one derivative away from each other. Okay, moving to the right, we're one derivative, I'll do D for derivative, away. Okay, but when we move backward, okay, these are grouped together. These are grouped together. When we move backward, we are going to the opposite derivatives. I would have to integrate to get here. And I would have to integrate to get here. So I have the rate, which is A of t. Okay? I need the quantity. Okay? If I integrate my rate, I get the quantity. And that's exactly what we're going to do. Boom, bang, bam. Right, so I'm going to integrate my A of t dt. Okay? Okay, so starting from the beginning all the way to time 4.5. That's all I've got to do. And of course, this is what I'm putting into that integration. A calculator is required for these problems. The directions tells you that. So that's exactly what we're going to do. I'm going to go to math and pick option 9, which is my integration. Okay, lower bound 0, upper bound 4.5. And now I put in my equation, parenthesis, 2x minus 5 parenthesis, plus, that's a minus, plus 5e raised to the 2 sine of x. Now I'm using x's obviously in the calculator instead of t. Dummy variable is x, ba-boom, and I hit enter. All right, and if I do this right, I should get exactly 66.532. Bring this out here because I can. And this will stay at 2 because the number after it is less than 5. So I'm going to say 66.532. This does not say with appropriate label, but this is liters per hour is the rate. If I go backward for the quantity, liters. Liters. There you go. That was easy for A. That was easy. It will start to get tougher. 2B. Now, I just copied a picture of the graph and brought it over here because it's nice for reference. During the time where T is between 0 and K hours. Okay, K is familiar. That's from the initial problem. We'll go back and look at that in a moment. Water flows into tank B at a constant rate of 20.5 liters per hour. What is the difference between the amount of water in tank A and the amount of water in tank B at time T equals K? All right, so first of all, let's go back at our problem. And all right, K. Well, it says that these two graphs intersect, okay, I'm highlighting in yellow, at T equals K and at 2.46. Well, I mean, I might be no calculus teacher. That looks like it's about 2.46, which means this is going to be your K value, whatever X is here. Okay? So K and 2.416. I'm just going to go right here, and because I can, this right here, we'll call our 2.416. And this intersect, that's this first one, this intersection point is K. It has an X value of K, or in our case, it's T. It's not X. All right? So they want to know the difference in the amount of water from tank A. Remember, tank A is this graph right here. I'm going to go right to here, because they only want from 0 to K. All right? So I just want that section. The difference between A, which there's my rate, and I have an equation for A. That was already given to me. That was 2t minus 5 plus 5e to the sine. Is that 2t? Let's go back and look. Yep. Plus 5e2 sine of t. Okay. Yep, we're good. That's exactly what it is. But we don't have an equation for B. What they did tell us, which is really, really important, is that water flows into B at a constant rate of 20.5 per hour in this interval. So from 0 to K, this line for B is a constant straight line. It's like y equals 20.5. After that line, okay, after that, it looks like it's at it goes out. It's not a constant anymore, okay? But before we get to K, from 0 to K, our equation is 20.5. It is a constant line. So I can definitely integrate the difference between 0 and K. The only problem is, and let's set up our integral first. I'm going to integrate. And I always want to take the bigger function minus the smaller function. Okay? The problem is, how do I tell? Starting at the x-axis, the bigger function is the one that's higher. The red is definitely higher than the blue. So b of t is definitely higher. So I'm going to take 20.5, because that's what my y equals, 20.5, minus the smaller function, 2t minus 5 plus 5e to the 2 sine of t, okay? This has to be in its own little world here. I'm subtracting the whole thing. Don't forget your dummy variable, dt. All right? Here's the issue. My lower bound is from 0. My upper bound is k. I need to figure out what k is. Well, guess what? I'm going to put this in y1. I'm going to put this in y2, and I'm going to see where they intersect. Okay? Again, a calculator is required. Bam. Turn this on, go to y equals, and parentheses, 2x minus 5, again we're using x instead of t, plus 5, e raised to the 2 sine of x. That's a of t. And let's see where that crosses with 20.5. Boom. Right there. Now remember, I really only want, okay, I really only want, wait for it, oh, I don't see 20.5, do I? Because my Y window only goes from 0 to 10. I need to go up to 20.5 in my Y window, okay? I'll call it 25. And does it give me an interval? No, 0. Well, if I look on my paper here, K is less than the number 1, okay? But let's go from 0 to 2 on the x-axis. Okay, let's just look at this part. We don't have to change that, but I like to be precise if I can. Let's go 2, 0, and let's graph that. I don't even need negatives here, but I go -5. Let's graph that. All right, there is my A of t in all its glory, moving slow as a snail. All right, and 20.5, there we go. Bam, that's where they cross. Remember, we said it should be close to 1. So here it is. I mean, it's going to be down here somewhere. That's close to 1. Let's use our intersect function and figure out what that is. I'm going to go second trace intersect. Okay? Just put close, hit enter 3 times. Bam, bam, bam. That is 0.89204,028. Let's use 0.892 for the sake of our paper. Okay, but when we calculate things like the integral, we're going to want to use that. And instead of retyping it, what I like to do is, right now in x is that value. I'm going to store that value into k. So now, for the sake of the problem, anytime I use k, it'll be our whole number unrounded. Okay? So here we go. Boom. 0.892. So now I'm going to integrate this whole thing from 0 to 0.892. 0.892. That's our k value. Good. Good, good. Well, we're not even done with b yet. We just, we set up the integral. We figured out the bounds. Let's go. Let's go. Boom. Move this down here. We're going to integrate that whole nasty thing. And I'm going to say, math, 9 is an integral. I'm going to go from 0, and I'm going to put k up here. Because remember, I stored my answer into k. K right now, until I store something into it, something else, or I clear my calculator, will have that long number. All right? And now I take my bigger function, which is 20.5, minus the entire smaller function. So I got to put parentheses even to start it. 2x minus 5 parentheses plus 5 e raised to the 2 sine of x. Boom. I pop out. I close that whole smaller function. My dummy variable is x. The difference in liters, okay, between A and B from time 0 to time that 8.892 is 10.599 liters. Okay, again, that's a 9. It'll stay a 9 because the number after it is less than 5. So 10.599. Choice, or actually, part C, 2C, the area of the region bounded by the graphs of A and T and B and T from K to 2.46 is 14.470. Well, we now know this is 0.892. Okay? So between here, which is 0.892, 2.92. And here, which is 2.416. This whole area, okay, wait, the area of the region bounded by the graphs. So they're talking about, okay, between graph A and B is 14.470. Okay, if it is bounded, that means the boundaries are my A graph and my B graph. So in between the graphs, between K and 2.46, okay, is 14.470. How much water's in tank B at time 2.416? Okay. We knew that this was a constant, but we don't know the equation for this right here. So I really can't do the area under the curve there. What I'm going to have to do, all right, what I'm going to have to do is I'm kind of have to use a type of geometry. Oh, look at that. Let's just let's just get rid of those altogether. That's a lot there happening. All right. So what I'm going to have to do is to figure out the area. And let me, I'm saying this slowly. Okay. We know that this is a constant of 20.5. So what I'm going to have to do, okay, is I'm going to have to take, okay, they want all this area under the curve of B from when it started right there. This is what we want. Okay, I'm going to tell you right now, we already know this. I can just integrate from 0 to 0.892, my 20.5. I can do that. Okay? But I don't have an equation for the second part, between K and 2.6 for B. All right? What I'm going to have to do is, I am going to have to, this might get messy with the purple, take all of the area under the curve for A, okay, I'm going to have to take this whole area under the curve for A, and I'm going to have to subtract my 14, wow, there it is again, my 14, oh boy, I'm going to have to subtract my 14.470, oh boy, we don't want to erase it. Okay, so I'm going to take this whole area and subtract this. Okay, whatever that is, by the way, I'm going to have to add to this. Okay, because they want this whole yellow part. Okay, so I'm going to have to add my blue part to this yellow part. And the yellow part is all of A minus 14.470. So let's start. Let's start, shall we? First, let's do the easy part. Let's do this blue part right here. Okay, I'm going to integrate from 0 to K, which on my paper I'm going to put 892 of 20.5 dt. All right? In the calculator, we still have that long decimal stored in for K. Don't believe me? Boom. Let's check. It's still there. So I'm going to math 9 from 0 to my K value, 20.5. Yeah, okay, I forgot to put the dummy variable. See, it's important, kids. Boom. And that should give me 18 points. Okay, we're going to keep this, change this to a 7, because a number after it's 5 or bigger. So it's 18.287. 18.287. That needs to get added to the yellow part, okay? Because I want all of this under the B. Okay, I have the green, I don't have the yellow yet. Just as a review, how do we get the yellow? We're going to integrate A from K to 2.416 and subtract 14.470. Okay? Okay. All right. So here we go. We're going to integrate from K to 2.416. Okay, and that's our 0.892 is K. Let's not forget our A of T dt. When I get that, I'm going to subtract my 14.470. All right? And that should give me just what's on the board in red, okay, or yellow, okay? So let's do this. Let's do this. Do I have a thing up here that has that big, long monstrosity written in it? I do. I can delete that. Would it be easier? Nah, I think I'm just going to retype it. I was looking to be lazy, but Math 9, from K is the lower bound, to 2.416. Let's make sure I got that right. I do. And I've got to do my A function, parenthesis, 2x minus 5, parenthesis, plus 5, e raised to the 2 sine of x, boom. Bam. Bam. Dummy variable, it won't integrate unless I take the dummy variable of it. So I've got 44.497. This will say a 7 because this is 5 or smaller. It's smaller than 5. So 44.497. 44.497. I need to subtract my 14.470 because, again, that 44.497 gives me, I don't even know what color is going to show up. Let's just do black. That 44 is all of this. Remember, we only want what's in red or what's in yellow there. So we got to take away that top 14,470. Take my answer minus 14.470. And I get 30.027. 30.027. This area here is 30.027. Oh my God. We just need to do one single addition operation and we're done. I want, oh, let's do something crazy. Let's do a crayon, orange crayon. Remember, we just want the area under B. I'm just going to add those two together. So I've got 18.287 plus 30.027. We get 4, 11, 3, 48 liters. I should probably put that in a calculator to double check it. All right, I'm going to take this here, and I'm going to take my answer, which was 30.0. I'm going to add that to 18.287. 18.287. I mean, we've come this far. Wouldn't it be an absolute shame if we made a simple addition problem, an error in that, and we've come this far and done all this great math? 48.314. Woo! Liters. There was a lot of explanation here. I know sometimes I talk fast, which is a weakness of mine, and I'm working on it. But if you need to rewind back or slide that little freaking little doohickey thing on the little time bar there, or whatever they call that, I don't know. I don't know nothing about technology. And go back and rewatch some of those things. If there's something you didn't get, go back and watch it. Because when you get it, it makes sense. If you don't get it, it'll never make sense. One more section to do right here, D. And D states, during the time interval where T is between 2.7 and 4.5 hours, the rate at which water flows into B is modeled by W of T. Thank goodness they finally give us an equation for the rate of B. And they say it's this right here, W of T. It's this equation. Liters per hour. It's a rate, so it should be quantity per time. All right? The difference between W of t minus A of t, the difference, I'm subtracting them, is it increasing or decreasing at time 3.5? Show the work that leads to your answer. After doing a complicated problem or two, this is really nice. Do not overcomplicate it, please. Okay? First of all, these are rates. Okay? If I want to see if something's increasing or decreasing, that makes me think of slope or rate of change, right? If something's changing, which means I want the rate at which this changes, which means slope is the same thing as derivative, right? So I want the derivative of this minus the derivative of this. Okay? Are those rates, is it the difference in those rates increasing or decreasing? And I want that at 3.5. So I'm going to take W prime of 3.5 minus A prime of 3.5. And by the way, your calculator has a derivative function just like it has the integral function. And that's all we're going to do. All right, W is new here, so I'm going to move this here so I can see the W function. That's underscored in blue. All right, math 8, my x variable, 21 minus alpha y equals, enter. Okay, the fraction of 30x over, parenthesis, x minus 8, parenthesis, squared. I want that when x is 3.5. Boom. That is my W of t, the derivative of it, the increase or decrease of that rate at 3.5. Now, we do the same thing for A of t, and then we take the difference of them. That was 2x minus 5, parenthesis, plus 5 e raised to the 2 sine of x, boom. Pop out there. I'm taking the derivative of that. The derivative of that at 3.5, boom. Now I just subtract the 2. I take W of t, and I subtract A of t, those rates. Oh, I have everything right here. So if you want, you can write these numbers down, but this is negative 1.14. 3. They should go up to a 3 because the number after it's 5 or bigger. If it's negative, it's decreasing, so it's decreasing. Answer the question. Decreasing. Show your work. I just did. I put W prime of 3.5 minus A prime of 3.5. Show the work, and there you go. Okay, so just to reiterate, I'm going to move this here. Here's W prime of 5. All right, yeah, I'll be okay, of 3.5. 3.5. Here's A prime of 3.5. And here's what happens when you subtract them. We subtract them. All right? There you go. That was real easy compared to everything we just did. We are done. Ring a ding ding like that bell. Give me a follow because we're not done yet. We still have questions 3, 4, 5, and 6. We have 4 more questions. And then maybe I'll do another AP exam. We'll see. Have a good one. And I know I'll see you later.